Good morning, students. Kinetic theory of gases, part 2. Ideal gas equation concept. Generally, if I am going to consider n moles, for n moles, what is the ideal gas equation? PV is equal to nRT. Here n is equal to number of moles. And P is equal to pressure, V is equal to volume, R is equal to universal gas constant, and T is equal to absolute temperature. Absolute temperature. So for n moles, PV is equal to nRT, n is the number of moles, P is equal to pressure, V is equal to volume, R is equal to universal gas constant, T is equal to absolute temperature. This is for n moles. Now, what is the different situations, ideal gas equation, how to change, we will see today now. For 1 mole, what will happen? Second one, for 1 mole. So in place of n, write down 1 mole, that's all. That means PV is equal to RT. PV is equal to RT. That is for 1 mole. Second one. So here again P pressure, V volume, R universal gas constant, T the absolute temperature, PV is equal to RT. Ideal gas equation for 1 mole. Suppose we know that 1 mole means how many number of molecules? 1 Avogadro number of molecules. 6.023 times 10 to the power of 23 molecules. That is only we are going to say 1 mole is equal to Na number of molecules. Now the question is the third one, ideal gas equation for 1 molecule, how to write? For 1 molecule of gas. For 1 molecule of gas, how to write the ideal gas equation? For 1 molecule of gas, we know that for n moles or 1 mole. For 1 mole, what is the ideal gas equation? PV is equal to RT. This is for 1 mole. This is for 1 mole. 1 mole is equal to what? Na molecules. So this is for, I am going to write ideal gas equation for 1 mole. So this is for 1 mole of a gas. PV is equal to RT. Observe here, Na transpose to left side. So 1 by Na mole is equal to 1 molecule. Molecule means 1 molecule. That means 1 by Na mole means 1 molecule. Observe here, this is for 1 mole. So PV is equal to nRT for n mole of gas. But if I require 1 molecule of a gas, 1 molecule of a gas, 1 molecule of a gas. What is the meaning of 1 molecule of a gas? 1 by Na mole. That's why for 1 mole RT, PV is equal to nRT for 1 mole. For n moles, PV is equal to nRT. For 1 by Na mole, that is nothing but 1 molecule. 1 by Na mole, that is nothing but 1 molecule. That's why for 1 molecule of a gas is nothing but 1 by Na mole. Then what is the formula? PV is equal to 1 by Na RT. RT. So this is the ideal gas equation for 1 molecule of a gas. This is the ideal gas equation for 1 molecule of a gas. That's why this can be written as PV is equal to 1 by Na into RT, and we can written as this one as a PV is equal to R by Na into T. Here PV is equal to, This R by Na. R is the universal gas constant. Na is the Avogadro number. So the ratio of universal gas constant and Avogadro number we known as Boltzmann constant K into T. So PV is equal to KT. This is the ideal gas equation for one molecule of a gas. That's why for one molecule of a gas, how to write the ideal gas equation? PV is equal to KT. What is K? R by Na. Universal gas constant by Avogadro number ratio, that is known as Boltzmann's constant. So where K is equal to Boltzmann's constant. Note down, students. Now, ideal gas equation for n molecules of a gas. First one. Fourth one, ideal gas equation for n molecules of a gas. N molecules of a gas. So if I am going to consider for one molecule of a gas, PV is equal to KT, where K is equal to Boltzmann constant, and it is nothing but ratio of universal gas constant and Avogadro number, of course. For n molecules, how to write this one? This is for one molecule. For n molecules, n times KT, that's all. For one molecule, PV is equal to KT. So now for n molecules, PV is equal to nKT. So this is the ideal gas equation for n molecules. N molecules. Here P pressure, V volume, N number of molecules. So n molecules. K Boltzmann constant, T the absolute temperature. This is the ideal gas equation for n molecules. N molecules. And now we are going to see ideal gas equation for 1 gram of gas and some x grams of gas. Here we know that we are going to calculate ideal gas equation for 1 gram of gas. Let us see. If I am going to consider number of moles, is equal to the mass of a substance. Mass of a substance, or your substance is gas. So mass of a gas, or mass of any substance, of course. Here the substance is gas. So mass of a gas is equal to, in kinetic theory of gases, we are going to consider the substance is a gas. So mass of the gas, that is also in grams. Don't forget. Here the mass of the gas should be in grams by molecular weight. Molecular weight. This is the number of moles formula. So we know that for 1 gram of gas means number of moles is equal to 1 gram of gas means for in place of mass of gas, write down 1 gram, that is mass in grams. So 1 gram by molecular weight. Molecular weight. We know that for n grams of n moles of a gas, ideal gas equation. For n moles of gas, what is the ideal gas equation? PV is equal to nRT. This is for n moles. So this is the number of moles. In number of moles, if I am going to consider 1 gram of a gas means number of moles is equal to mass of the gas by molecular weight. That's why PV is equal to, in place of number of moles, I am going to replace its equivalent. What is that? Mass of the gas. Mass of gas. That is also in grams. That is must and should. In grams only we need to write. By molecular weight. Molecular weight. Molecular weight into RT. Of course, this is the ideal gas equation in terms of molecular weight and mass of the gas. Suppose I required ideal gas equation for 1 gram of a gas in the problem. Then how to write it directly? Let us see, PV is equal to mass of the gas in grams I need to write. I have only 1 gram of gas. That's why that 1 gram of gas by the given gas molecular weight. The given gas molecular weight. The molecular weight. I'm going to write molecular weight with the symbol M suffix W. That is molecular weight into RT. So PV is equal to 1 by molecular weight into RT. This is the ideal gas equation for 1 gram of gas. For 1 gram of gas. So ideal gas equation for 1 gram of gas, what I am going to get? PV is equal to R by molecular weight, 1 times R. So R by molecular weight into capital T. So this is the ideal gas equation for 1 gram of gas. But here, this is I am going to write in another form also. How to write? Let us see. PV is equal to R by molecular weight. It is nothing but we are going to consider it is represented with a small r. So r is equal to why? Because r by molecular weight I consider small r into T. So this is the ideal gas equation for 1 gram of a gas. So a small r is called specific gas constant. So specific gas constant is nothing but the ratio of universal gas constant by molecular weight. This is the m suffix w, molecular weight. So for 1 gram of a gas, how to write the ideal gas equation? PV is equal to small RT. Otherwise, PV is equal to R by molecular weight into T. That is for 1 gram of a gas. Directly write down this formula to solve the problems. If in the problem 1 gram of a gas is given, directly use this formula, ideal gas equation, solve the problem. Here this is the universal gas constant, this is the molecular weight of a given gas in the problem. So absolute temperature. So now ideal gas equation for the sixth one, for x grams of gas. For x grams of gas. So for n moles, ideal gas equation we wrote for n moles and 1 moles, and the third one n molecules, 1 molecule for 1 gram of gas and x grams of gas. Totally 6 forms we are going to write. Ideal gas equation, the sixth form is for x grams of gas. How to write for x grams of gas? For 1 gram of gas we know that PV is equal to small r into T. This is what? For 1 gram of gas. What is R here? Universal gas constant by molecular weight. The ratio will give the specific gas constant. A small r is the specific gas constant. So this is for 1 gram of gas. I require for x gram of gas. Then PV is equal to, for 1 gram of gas, PV is equal to RT. For x grams of gas, PV is equal to XRT. That's all. Suppose in the problem is given specific gas constant and x grams, that is 5 grams, 10 grams, 100 grams, like that is given, means use this formula to solve the problem. Suppose in the problem is given x grams of gas, that means 5 or 6, 7 grams, anything is given, and the molecular weight given in the problem. Otherwise, we need to know the molecular weight of the small gases. And some gases we need to know the molecular weights. Even though not given also, we need to use the molecular weight and universal gas constant to calculate specific gas constant. And this is the ideal gas equation for x grams in terms of specific gas constant. In terms of universal gas constant, how to write this equation? PV is equal to x into, that is x grams of substance or x grams of gas, into what is small r? Universal gas constant by molecular weight into absolute temperature. So this is also another form for ideal gas equation of x grams of gas. Ideal gas equation for x grams of gas. So PV is equal to XRT and PV is equal to x into R by molecular weight into absolute temperature. These two are equivalent forms only. These two equations are used for x grams of gas, ideal gas equations. And this is in terms of specific gas constant, and this is in terms of universal gas constant and molecular weight. These two are equal only. Why? Because specific gas constant is nothing but the ratio of universal gas constant and molecular weight. R by molecular weight will give the specific gas constant. Thank you, student.